As the machine learning technology advances, these days we see some remarkable results from machine learning method, especially in the area of image processing and speech recognition. We see some very nice results, which is shown here. So this shows the performance of machine learning, especially deep learning, in the area of voice recognition, speech recognition. So here, this dotted line represents the performance of human voice recognition, and this red curve represents the performance of deep machine learning, especially deep learning. So as you can see here, it keeps growing, and around 2017, this deep learning performance now outperforms the performance of human. And also here, down here, this shows the performance of image recognition here. So again, this dotted line here is I'm sorry, this line here is the human level accuracy. So this blue bar shows the performance of, again, deep learning. So again, and around 2017, this performance actually exceed the performance of human level. So yeah, roughly speaking, in the area of image recognition and speech recognition, the deep learning, machine learning, especially the deep learning method, kind of outperforms the accuracy of human level. So there are some other results from machine learning, especially in deep learning. In this case, if you give an image like this, the algorithm is going to generate sentence like this, which describes the image. Or these days, more recently, it goes the other way, saying if you give a sentence like this, then an algorithm is going to generate image based on your sentence. And there are some other applications like this. If you give an image, this is traditional application. So machine learning recognize objects in the picture. And this is the example of autonomous vehicle. And this is, as you know, this is famous AlphaGo is an example of applying machine learning. Actually, it combines deep learning plus reinforcement learning. So this shows some example of generative learning. In particular, it's this example of a network. So if you look at the first one here, the GAN generates its image like this. So who is she? Who are these ladies? Actually, these are not a real person. These are artificial or synthesized image. Okay. So what's happening here is you have a lot of images of celebrities, famous actresses, something like that. Okay. And then you train again using those images. Then after that, you ask the GAN algorithm to generate image. So that's the result of GAN. So again, by training this, by using a lot of celebrity images, it generates very clear images of women. Down here, actually these are movie clip. Okay, movie is another picture. So what's happening here is, so this is original movie, and then you ask the GAN algorithm to transform the original horse into zebra. Okay, then this is result. Okay, so these days the result is so accurate, so clear. It's very difficult to tell which one is real and which one is fake. Okay. So this is another example of generative learning, especially in this case, is the example of using GAN. Yes, this is another interesting application of deep learning. So what here is you train your deep learning, in this case again, and using a lot of the Van Gogh painting. Okay, so your GAN algorithm is trained by using lots of Van Gogh painting. Okay, and then later when the training is done, you give a new input image like this. Okay, and then you ask the algorithm to paint this. Okay, then the algorithm draws something on top of this. Okay, and so this is the result. Okay, this is based on the original image, but it looks quite like a Van Gogh, right? So that's the very interesting example of the deep learning, especially again. And down here, what's happening here is, for this case, you have lots of night images. Okay, you have a lot of images at night. Okay, you train them using night images. Okay, and then you give this day image as an input. Okay, then ask the algorithm to transform this into night image. Then this is the result. So this original input day image now is converted to night image. Something similar happens here. So you have a lot of grass image here. Okay, field image here. Actually, this is summer time. And then you when you give this winter image here, then the algorithm is going to change this winter image to summer images. Okay, so that's another very interesting application of deep learning. So this shows the progress of images generated from machine learning algorithms. So in 2014, as you can see, the image is not impressive at all. It's unclear, it's fuzzy, but over time, in 2017, the image now is very clear. It looks so real. So it's almost impossible to believe that this image is artificial one. So let's say 10 years from now, you can imagine what kind of image or video this algorithm is going to generate. Down here, these days, machine learning algorithms also generate music. So for example, from the Magenta project in Google, they generate a lot of music there. So yeah, as a break, let's take a listen some of them, one of them, and I hope you enjoy it. Yeah, I hope you like it. So far, we have seen the definition of machine learning and the advantages of machine learning, and also some interesting applications of machine learning. So for the rest of this chapter, I'm gonna talk about a little bit of some issues in machine learning in general, and some, say, problems maybe of machine learning. So some caveats of machine learning. There is an interesting theorem called no free lunch theorem in machine learning. The algorithm goes like this. Suppose there are two classifiers H1 and H2. Classifier is a classification algorithm in machine learning. So let's say you have two arbitrary classifier H1 and H2, and also suppose H1 shows better performance than H2 in some domain D1. Okay, domain is data. Okay, so H1 is better than H2 in some data D1. Okay, then there are some other data D2 where actually H2 is better than H1. Okay, so it goes like this. Okay, so for a classify H1 and H2. Okay, H1 is better than H2 in some data D1. Okay, but for other data D2, okay, then in D2, actually H2 is better than H1. Okay, and there always exists such data D2. Okay, that is a no free lunch theorem. Another way of saying this theorem is, so if you compare two classifier H1, H2 for every possible domain, okay, so suppose, okay, this is unrealistic, but suppose you have every possible domain you can imagine, okay, suppose you have that data. Then if you compare this classifier H1, H2, actually there is no winner. These two classifiers are actually equivalent. Okay. So in this case means suppose you have every possible domain you can imagine, okay, in your world, then no classifier is inherently better than the other. Okay. That's a no free lunch theorem. So if you have every possible data, two classifiers are same. Then the next question is then why do we prefer one method, one algorithm to others? Okay. For example, we people prefer deep learning these days to other method. Let's say decision tree. Okay. And also we know deep learning or deep reinforcement learning shows better performance than other algorithms, right? So why is it? The reason is we cannot have every possible domain. So here it says if we have every possible data, then these two classifiers are equivalent. But this is unrealistic. Okay, you cannot have this. We cannot have every possible data domain. The reason is our world is full of biases. So when I say bias, I mean every physical law or chemical law or mechanical rule or our social law, science or whatever, everything, okay? And these are, when I say biased, these are the example of biases here, okay? Yeah, for example, people cannot live under the sea, we cannot fly, okay, etc. Okay, everything is bias, okay? Our world, we are surrounded by biases, okay? So because of these biases, the data we use, okay, this data, domain data, is generated from our world, and because of these biases, this data also has biases in it. So every data we have has bias in it, okay? So machine learning is using this data, okay, and the goal of machine learning is actually to learn these biases in the data correctly and efficiently. So we're gonna learn many machine learning algorithms, and actually the goal of machine learning is to learn the bias in the data correctly and efficiently. Okay, so learning is about learning bias. Okay, so learning bias is the most important key in human learning and machine learning as well. So in human learning, as a human learning is about learning bias in nature, and machine learning is actually about learning bias in data. Okay, so that's the kind of summary of no free lunch theorem. So machine learning shows excellent performance in many areas, including the image processing. But again, nothing is perfect, and machine learning algorithm in image classification still has some issues. So this slide is one example of that. So if you here left hand side, this is the image of dog. Okay, this is the original image. And if you add just a few pixels of noise here. So this is original image plus some just a little bit of noise. Then the state of art classifier, image classifier, classified this as ostrich. See, originally this classifier classified this as dog, and just a few bit of pixel, then now it's classified as ostrich. So as a human, we don't see difference between these two images. I myself cannot see the difference. But from the eyes of machine learning, there may be some very delicate area, very sensitive area, which we cannot recognize. Okay. So again, so that's an issue in the even in the state of art classification algorithm. So as more and more machine learning algorithms are used in our daily life, actually we provide more data to the machine learning algorithm or machine learning company. Yes, in return, the machine learning algorithm give us some benefit or convenience. But the problem is the more data we provide to the machine learning company, the less privacy we're gonna have. So there is a tension between machine learning and our personal privacy. So for example, yeah, almost everyone uses Google these days, and looks like Google knows pretty much everything about us. This slide actually is not about machine learning, but I thought this slide is interesting. This picture shows the relationship of web pages in many different languages. So, for example, here these are the web pages written in German language, and let's say this is web pages in Polish, etc. So let's say we have this edge here. That means many Polish web pages making reference to German web pages, etc. Okay, and we have a Chinese, we have Russian, etc. Okay. The reason I put this slide here, even though this is not related to machine learning, is as you can see here. Yeah. By the way, English is not mentioned here because English is so popular. Okay, almost every web page refers to English web pages. So English not is skipped here. If you look carefully here, we don't see Korean language here. Okay, we don't see Korean. We do have Chinese, Japanese, Malay, Indonesian, but we don't have Korean. So it's interesting. So what it means is actually the Korean language, Korean people have virtually has no interest in any other language website, and at the same time, foreign language site, whatever, actually has virtually has no interest in Korean language sites. So I think this is problem. I'm a little concerned about this. Okay, so in a cyberspace, in a web space, Korean language, Korea is kind of isolated. Okay, so it's kind of frog in the well. So there's a little problem here. So that's why I put this picture here. Okay.